Hi, dude. How's it going? Yeah, good to see the channel still up real. I'm sure everything's probably gonna be fine. I just wasn't too, like, I was just concerned because I looked so much shit up and, like, so many people said that their channel got terminated from that shit and it was, like, you know, really scary. But I think it's fine. I went through and I got rid of a bunch of stuff that would have been bad anyway, so. I'm just gonna have to hope that everything's fine, which it probably will be because it was, like, only one person. It's not like a bunch of people reported it, so. No, not the fucking exasperation song. Are you crazy, dude? Dear Lord. Yeah. Just because, like, this is a college math class or whatever, most of you aren't gonna know what the hell's going on, but, you know, hopefully you can just stay and talk. This is really just because, like, I figured it'd be fun to try to do this on stream. I don't know. I don't usually study on stream because, like, who wants to watch that, but I think we're good. Let me check my volume real quick. I think we're good. Yeah, seems fine. Alright, well, I guess let's just get started. Alright, I'm just working off of, like, a thing that my teacher told us to practice. It was, like, kind of a homework assignment, but also not. So, like, I mean, I don't know. Also, you know, if anyone watching this already knows how to do the thing that I'm doing, or is, like, I don't know, just, I'm usually a fucking idiot, so just, you know, you can be helpful, but just, like, don't make fun of me if I fuck anything up, goddamn. So, here, we got this first one, which I already know how to solve this, but I might as well just write each one on here. I don't fucking know. So, yeah, this is just, basically all these problems are just gonna be test for series convergence or divergence, and if it converges, you have to say if it's conditionally convergent or if it's just absolutely convergent. So sure, guess randomly. Alright, so in this case, this will diverge if we take the limit of the sequence and it is not equal to 0. So you can already see, like, if you took the limit of this, then goes to infinity, of all this junk, you get, well, here's a quick shortcut. Instead of having to use L'Hopital's rule the whole time, well, I mean, you are using L'Hopital's rule, but, like, instead of having to, like, differentiate it each time, if the degree of the top, like whatever the highest degree is, this limit is going to be equal to the ratio of the coefficients for those. So in this case, we technically have, like, an invisible 1 in front of this n squared, invisible 1 in front of this n squared. So this limit's just going to go to 1. And because 1 is not equal to 0, this diverges by the test for divergence. This is beautiful. What an amazing problem to start with, honestly. What a certified banger. Just the classic, you know. I'll try to rechat as much as I can since I'm not, like, playing a game. Yeah. I mean, the channel, I can't say with, like, 100% certainty that the channel has been scrubbed clean. But, you know, there's a good chance. All the videos should be scrubbed clean. I'm probably going to go back through and, I mean, this sounds kind of sad, but at the same time, I don't think anyone's going to care because no one watches them anyway, and they're not even, most of them aren't even accessible because YouTube bugged out on the playlist. But I might just go back and delete most of my old streams that aren't, like, completion streams because I already have the highlights for them anyway, and, like, I just don't want to risk anything, so I'm just going to have to be extra careful from here on out as well. Alright, let's move on to the next problem, shall we? We have sum from 1 to infinity of n minus 1 over n squared plus n. Alright. Oh yeah, I can call, sure. Oh yeah, also, before anyone asks, I just don't have my face cam on right now, because, like, it just didn't seem necessary, so. Where is... yeah, okay. Alright. Also, I don't know how long I'm gonna be streaming. Like, I mean, it's like 11 p.m. for me. I'll probably study for like a good hour before I end. I don't know. This is Calc 2.
My birthday's in 2 days, and I come back on the 17th, and I have to finish all this makeup work I've missed so far.
Let's go.
As ass. Oh my god.
Blake gets more viewers on a mass study stream than most small GD streamers. I mean, not really, because everyone's about to start peeling out here, I have a feeling. we're probably going to be averaging like 3 viewers for this whole thing, but I don't really care, because the point...
yeah, probably.
It's just a study stream. Okay, either way, we can see that the degree of this top term is 1 less than the lower term, so this limit is... I'm not going to bother writing it out, but this limit as n goes to infinity is just going to go to 0, so that tells us nothing about it, because if it goes to 0, it could either converge or diverge. So the next thing that we want to do...
I'm so happy I don't have math right now. Oh
yeah.
My God. I don't have the time to deal with it at all, right? This is ass, dude. I'm only doing biology and like a little bit of hard drafting work so far, and like food is easy. And my English class is kicking me in the ass right now. It's so hard, dude. Oh my god. I'm losing my mind.
Okay.
I'm actually going crazy.
I'm in Calc BC, but I haven't got to sums yet. You're not gonna really do, at least from my experience, you shouldn't really do any of this in Calc. Like, if you're just taking AP Calc, you're not gonna touch this. This is Calc 2. It's just like, it's just series and sequences. You're on derivatives right now? Okay, yeah, you got a ways to go. Derivatives are like... well, I guess derivatives are probably like the easiest thing about Calc, maybe. I think they're... I mean, they are. I'm pretty sure. I don't know what else is easier within Calc.
To do these two
okay,
let's...
Alright, sorry, I'm like... I need to actually like get on with studying too, so... Alright, so this limit goes to 0, so it doesn't tell us anything, so... My first thought on this one is probably a comparison test of some kind. So if we can come up with a series that we know how it behaves, we can use either a comparison test or the limit comparison test. The only problem is I don't fully remember like the rules for convergence and divergence on the limit comparison test, but let's just think about this. So
these bell ringers.
So we have n minus 1 over...
I look online.
So we have n minus 1 over n squared plus 1. So... we can, Ooh, I actually did think of another way to look at this. Because you could break this up.
Find a recipe you would like to prepare. Oh god.
Is Calc BC much harder than Calc
I need a
AB?
food recipe. Give me like a random recipe of a food. I need like some random bullshit to assign this with.
Baklava.
Because I cook it when I get back. What? I have to make this. Baklava. Okay. I'm gonna have to make baklava when I get back.
I don't know how much harder BC
I think
is
whatever
because
I make,
my high school only offered Calc AB, so I couldn't take BC, so I don't know how much harder it is. You know, if you're doing BC, maybe you will do this. I have no idea. Alright, so if you wanted to, you could split this up. I'm not going to bother writing the summation symbol just because, like, at this point it's implied and I don't feel like dealing with it. So we could split this up into n over n squared plus n, which the n's are going to cancel and you're going to end up with 1 over n plus 1.
Honey
right?
baklava.
And then minus, we're going to end up with 1 over n squared plus n, which... I feel like I could probably do something with that. That might actually make this easier. Because I think I'd have to do a limit comparison test if I did it. I'm probably going to end up having to do the limit comparison test. forget how summations work. Basically, you plug in each value for n going up to the upper bound, and then you add all the terms up. So, you know, you'd plug in 1 for this, then you add it to plugging in 2 for n, then you'd add it to plugging in 3 for n, all the way up to infinity. That's all it is.
Wait, I'm gonna move us to another channel real quick. Hold on. 1 second.
There is the integral test, but there's not a derivative test. I mean, maybe you could come up with a derivative test. I have no idea. Okay, so...
How are you today?
Good. So, basically...
You steady?
Yeah, so... Alright, so here's what we could do for... Oh, wait a minute.
Seth?
Yeah.
I want to show you. Can I show you an effect that I did
Okay,
real quick?
so we could say that... Okay.
I did on GD.
So we can compare this. We can compare this one to yeah. So basically, this right here can be compared because you can say let's move this son of a bitch aside. So check this out. This thing we can say is less than 1 over n, right? And and 1 over n 1 over n is the harmonic series which diverges. So if this oh wait no, I'm stupid. Wait, no I'm dumb.
I've never made a baklava
God
before.
damn
This
it.
looks so hard.
It's because it's greater than. Okay.
Honey baklava. Oh, it's
God.
a Greek baklava. Oh my god.
Your guess is that it diverges.
Oh no.
Alright, hold on. God damn it. I can't believe I'm already struggling
really
on this.
interested to see if he lets me make this.
Some of these are like
test or something?
Yeah, I have a test Monday. Okay,
okay.
hold on. So, is there a comparison test for the? Hold on. 1 over n is greater. Ah, no, this is what we could do. This series is clearly larger than like 1 over like 2n, right? Clearly. And 1 over 2n is a constant multiple of the harmonic. So this diverges. And if we did a comparison test on this thing right here, we could, well, actually we don't need to because this diverges. So that's it. This should diverge by the comparison test. It shouldn't be that bad. I mean, let's see. Was I right? Number 2.
Yes, Greek baklava recipe. Let's go.
Oh no, bro.
Attach.
They only gave odd solutions. God damn it. Classic math. Average math textbook L.
Wait.
Damn
Why
it.
is it slanting? I didn't even click that. What? Oh, is that the command?
Okay, this should diverge. Yeah. I'm pretty sure it'll diverge because, yeah, like you can split this up, you can work it down to here, and you can show that this piece of it diverges, so therefore the whole thing should diverge. I think we're good. So, you know, whatever. Diverges by comparison test with sum from 1 to infinity of 1 over 2n. So there you go. I think that's what we're gonna go with.
Oh,
seems
dude,
to be pretty easy.
I missed out, bro. We made muffins.
So
damn it. We made muffins on Friday, and I wasn't here for that.
Oh yeah, draw sap. You guessed it. Yep, it diverged. Crazy. All right, let's go to problem number 3,
Holy
which does have an answer, by the way. All right, let's see. Or well,
Dude,
the book provides an answer
I don't
for.
even want to check what my grades are.
I have no idea what's going on, but I wish I did. You'll know eventually if you decide to keep doing math classes if you hate yourself. So we'll take the sum.
For real, bro.
Well, see, I actually don't hate myself. I just like math, but you know, we're good. All right,
I hate math.
We're going from 1 to infinity of 1 over n squared plus n. All right, so.
Shit, I closed canvas on accident. Damn it.
So this one is just a simple comparison test. Obviously, the limit goes to 0. So comparison test. In this case, I would just say that this series is clearly less than this series, which is gonna be a P series. We'll just say 1 over n squared, right? And this is a oh my god, we have a P series with P greater than 1, therefore this thing diverges by comparison test with this.
Oh no, my grades.
Or
oh
I meant
God.
converges. I
God.
meant converges. Oh my god, I'm stupid. Converges.
Oh, my grades are tanking. Oh
Converges
God.
because a P series converges if P is greater than 1. Okay. I don't know why I do that. I for some reason I naturally write down diverges for like even if it's I don't know. So let's see, did I get it right? Yes, converges because P greater than 2, and that is indeed a comparison test. Easy. Alright.
Actually, I think the last time I was here is when I got 97 on decode. Like twice. I think that's the last time I was in this house.
Yeah.
Oh my god. Damn. I remember playing in this room. Damn, dude.
Alright, problem 4. We have the sum. Oh, we got an alternating series. Things are about to be
Rev, I have a
spicy.
question.
What?
Have you ever dropped a level before?
No.
Holy shit!
Has he ever what before? What?
Rev has never dropped a level before.
Yeah, because he plays levels that he likes, and if he doesn't like them, he just forces himself to play them.
Sorry, it's so funny.
It's like basically all of
Yeah.
Rev's like GD career. It's like if he likes a level and then he doesn't like it, he just completely tortures himself until he's done with it, and then he never plays it again.
Yeah. Alright, so this is gonna, times, alright, m minus 1. Yo, thanks for $2 Canadian. Vince is a gamer. Alright. So,
He said thanks for the $2 million.
the 2 million. Oh, I didn't realize how quiet this was.
Yo, thanks for the $2 million.
Okay, so, checks out. Basically, over n squared plus n, and in this case we can do the alternating series test. We just have to prove that it is decreasing for all values of n, and that the limit goes to 0. And in this case, this limit does go to 0. Let me know if I turn the music up too loud. There's a chance I did, because it sounds kind of loud right now, but it could be my headset. We have a textbook cam. So the class actually has a digital textbook that was just included with the cost, and I'm just using it on my phone. So, no. I mean, I guess I could show you a picture of all the problems at the end, I guess. I just have to...
You know, Rev.
Wait, is the music too loud?
Rev, you may be probably one of the best GD players when it comes to mindset-wise.
I mean, I guess.
Maybe even the best.
How do you even do this math?
I mean, it's not even like GD-wise, it's just like he has a like really strong willpower. He like
Yeah.
basically forces himself
Yeah,
to finish something.
I do
even
have
if he hates it
willpower.
so
That's
much.
one thing I have. You just
Like his endurance is crazy high.
if you just keep, I don't know, like this looks really hard to you because you just haven't like eased your way up through to it yet. Math's just one of those things where like each year seems like you're just gonna fucking fail, but then like you just don't because you realize, oh, it's not so bad because like it just
Like you you just randomly figure it out.
Well,
and it's completely free. and
no,
it's
not like
that every single year
not
for
like
me.
that. It's just like
For me, it's like
you just like
that.
ease into it. That's all. So, all right.
I
Either
don't
way,
even ease into it. Like I don't know what the hell is happening for a while, and then I'll like randomly figure it out.
Yeah.
Like, oh, this is.
so this limit is gonna clearly go to 0 because we have a higher degree on the bottom, and it's just a polynomial. So that's the first condition satisfied. So now let's check to see if it's decreasing everywhere. Oh my gosh, Vince! Thanks for the 10 Canadian dollars. Have another money. Okay, good night. I'm 1 hour ahead of you, and I work 10 a.m. tomorrow. Good luck with the. All right, yeah, thanks, man. All right. Gaming. All right.
I hope my English teacher will be mad at me now.
So,
Yeah.
we need to show that this is decreasing everywhere. So we have two options. We can either take the derivative and see if the derivative is negative, or we can just do it algebraically. In this case, algebraically is probably easier. So, well, maybe, let's see. Hold on.
What does it mean to do it algebraically? What?
Basically, we need to prove that a sub n plus 1 is less than a sub n. In other words, the next term in the sequence is gonna be less than the previous term for all n. That's what we need to prove. We need to prove this statement right here. So,
Oh my god, it's cold in here, bro.
what we can do is we can just. Oh wait, I feel like my chat's kind of. Oh yeah,
Let's go.
I'm moving the chat down because I forgot I turned my camera off, so it like, looks weird.
Rev.
What?
So you know how in some levels they have like that line of like glow that goes up and down and sometimes side to side, like during like beats and
Yes.
shit? Could you like teach me how to do that at some point?
Oh, I mean, I've never made that, but I mean, I could probably just figure it out really fast, I guess. Yeah.
Yeah, cause
Are you talking about like the flashes of glow? I think you just like use a move
Yeah.
trigger and then like move
Here,
a line of glow across the screen.
All
I
right.
guess.
Okay. Here,
Screen
let me
can I
finish
show you
this
this real
problem.
quick?
So,
Sure.
how
look
we
at
would
this.
do
I'm
this
doing
is we
homework.
just sub in. We
Yeah.
just
This is
sub
something I
in
made
n plus
or for
1
terrorists, but
for all of our n's. Right. So we end up with.
Are you like making the old version of Terrors or something?
And then if we
Yeah, I'm structuring it.
if we simplify,
structuring it.
well, n plus 1 minus 1 is just n, and then that's
and cool
over.
thing is, most of the bugs in terrorists were just because it wasn't structured.
Square
yeah.
it, twice the product, square it. And then we're adding an n on plus 1. Okay, so now if we clean this up, we end up with n over n squared plus 3n plus 2. Alright. Yeah, I should have just taken the derivative probably because I always end up doing this, bro. Sometimes I just don't know what the best way to do it is, and then I realize that I should have done it the other way because this is just too hard.
Dude, they had wings and fries at lunch on Friday, and I wasn't here. God damn it, dude! It's always the best food every time I'm not here.
We have like, so I need to get an n minus 1 up top to verify for certain. Huh. Yeah. Yeah, I'm just taking the derivative. God fucking damn it. Oh, okay. Let's take the derivative, guys. Okay, so if we differentiate this thing, then we're gonna end up with n squared, or not n squared. We're gonna end up with x squared plus x minus 2x plus 1 x minus 1 all over this thing squared. And we just have to show that this derivative is in fact negative, which yeah, I guess I could play the Yoshi's Woolly World OST in a second, maybe. Yeah, math test moment for real. Alright, Well, this is not looking very promising, I just realized, because this is really seeming like it's gonna be positive everywhere, because... Oh wait, no, because no.
Recipes.
Because if you distribute this, you're gonna end up with a bigger thing on the right side, so yeah. If you distribute that, you're gonna end up with 2x squared, and then minus 2x plus x, so minus x. And then you're gonna end up with plus or minus 1. And it's gonna be like it's gonna be the x squared plus x minus that, and obviously if you end up subtracting these, you're gonna end up with like a negative x squared term up top, so that's enough to show. So we can say that the dy over dx is less than 0 for all x on the interval from 1 to infinity. Therefore, this thing, this isn't like exactly proper, but converges by the alternating series test. Now, I need to go ahead and... Now we need to check for, since we use the alternating series test though, we need to check for conditional convergence or absolute convergence. So we just need to do that.
Oh yeah, I gotta know the difference between dicing, mincing, chopping, and cubing. Oh yeah,
Perfect.
This is great. But yeah.
Oh, we did cubes.
God. Yes.
Yeah, your
Yo,
entire
nice.
honestly, if you don't know this math, you'll probably be poor for the rest of your life, and you'll just live underneath of underneath a highway overpass, and you're.
Yeah, and you don't know if you don't know the difference between chopping, dicing, cubing, and mincing, you are going to die. You know, there's gonna be like some random demon that's gonna walk up to you in the middle of like you just don't expect it. He's gonna be like, "What's the difference between cubing and chopping?" You're like, "Oh,
yeah."
If you don't know, you're fucking dead.
So
like,
okay,
that's how that works. If you don't know the most unnecessary information, a random demon is gonna come out of your asshole and then just randomly ask you this question.
Yeah, pretty
and
much.
if you don't know this immediately, oh, you're dead. Yeah.
Oh yeah, guys.
1/4
So this is actually the same. If you, I just remembered this is the same series that we had actually. It's just now it's placed in alternating series, and that one diverged. So this is conditionally. Because this series disregarding the -1, this thing right here diverges. So we can say that basically cleaning this all up, we would say just say that this series
1/4 to 1/8 bench. Okay.
This series is conditionally convergent by, and then it would be the comparison test, because that's what says that it's conditionally convergent. So, and that's the comparison test with, if you recall, the series that we used to compare this was n equals 1 to infinity of 1 over 2n. So there you go. That is problem 4 done. So this is conditionally convergent.
What is pairing? Remove the stem and a very thin layer of peel of a fruit. What the fuck is that?
So
Dude, doing the exact same thing I've been learning.
I didn't know there was a
We have
name
the
for that. That's
sun.
actually interesting.
From 1 to infinity.
Alright, Rev, what's your
There's a name
favorite
for
what's
that.
your favorite math function to cook?
Probably the gamma
Tangent.
function. So 2 to the 3.
Tastes like sounds like it would taste like pumpkin.
What, the gamma
What the fuck?
function?
Yeah.
Well, no, it tastes like
Surface of a food.
it tastes like X factorial actually, so you'd be wrong.
Damn,
All right.
bro,
God
one more
damn
money.
it.
So for this one, this is screaming ratio test to me for some reason. I
I
mean,
thought you were about to say that. Never mind.
what could
Wait,
I
what do
have
you
possibly
say?
said? Okay, just don't.
Bro,
Yeah,
what-
I don't want to know. I don't want to know because
Oh, I already know. Rev, you already know what he was saying. You already know what he was saying.
What is this?
so
Slicing? Yeah, slicing.
so we need to use the ratio test, I think. I mean, or unless there's a clever thing I can sneak in here. So 3 to the n plus 1. Trying to think. Is there anything sneaky I can do here? I don't think so. I think we're just going to go ratio test. It just seems like a ratio test. So we're going to basically be taking the limit as n goes to infinity of the absolute value of... So, I mean, in this case, we can kind of just disregard the negative then. So really it's just going to be 3 to the... 3 to the n plus 1. Over... no, my bad. 3 to the n plus 1 plus 1, right? So n plus 2.
I love n plus 2.
Over 2 to the 3 times n plus 1, and then we're dividing by another thing, but I'm just going to skip a step and just multiply by the reciprocal right away. So then we're going to be times 2 to the 3n, or 2, yeah, 2 to the 3n over...
There's a thing for that?
3 to the n plus 1. Alright,
What's
so
up, Steph?
we just have to deal with this
You had a
limit.
new realization?
So if you take a look at this right here,
I did.
you can see that a few things are going to end up going away. Actually, here's what I would do. I would go ahead and distribute this. So instead of 2 to the 3 times n plus 1, we can make it 2 to the 3n plus 3. So this will help us out here because now some stuff is going to cancel. Or, I mean, not cancel, I guess, but divide out. So, in this case, we're going to be left with just a 1 on the bottom here, and we're going to be left with a remaining 3 to the first power up here. So we're going to be left with the limit as n goes to infinity of 3 to the first power, and then that's going to be over. So this goes to a 1, so that's kind of gone. And then these are going to divide out somehow. In this case, we're going to be left with a 2 to the third power, which is just 8. And then this also goes to a 1, so times 1, so really nothing. And this is actually going to be equal to 3/8. And since 3/8 is less than 1, this series would be absolutely convergent by
God, there's so
ratio
many of these.
test. There you go.
Dear God, dude.
Hell, I'm 18.
What's wrong? What?
Also, high comment. Dude, the waves in Acheron are so fucking stupid. Alright.
Guys, at some point, Rev's going to be 30 with children. Isn't that crazy?
Yep. Yeah, I don't know what this has to do with anything, man.
It has nothing to do with anything. So, 5.
Yeah, well, you find what 2 plus 2 is in the most complicated way after.
I'm not doing this again.
I
Okay,
already did
so
this.
3.
Yeah,
Alright.
you did that before.
You already did that.
Series-
What was the answer? What
Yes,
answer did you get?
absolutely convergent. Let's go. I did it, guys. I got 5 correct. Okay, let's move on to 6 and see what's going on.
Smooth.
How bad is 6?
Cut in.
Alright.
I see.
Oh god, this 6. Oh. Oh, 6 looks ugly. Oh my god. Okay.
Pastry blender that exists. Oh gosh. I'm going to whip out the pastry blender. Delicate mixture into a heavier one using a what spoon is this again? Rubber spatula spoon.
I found an album entirely comprised of songs found on abandoned cell phones in the Sahara Desert. Wow. That's crazy.
Is
All
that
right.
Chrome?
No.
Oh damn it! That sounded like a Chrome comment. Oh.
All right. So this is kind of goofing. Let me think about this here. We could try. I don't think they'd give me a telescoping series that has a trig function in it. I don't think. Is that even possible? It probably is possible. I don't know. Either way, I suppose the best. No, wait. This has a very nice solution because. Oh no, it doesn't. Wait, never mind. That doesn't work. Let's see. What can we do? That doesn't look very fun to integrate. Well. So I think integral test is out of the question. I don't see a comparison test that would work. Definitely not the root test. Definitely not the ratio test. Huh.
To beat quickly and vigorously by hand, wire, whisk, or mixer. Okay.
That's beating. That's called beating.
The word vigorously is just funny to me. I don't know why.
Yeah.
That's called beating.
To beat quickly and vigorously by hand with a wire whisk. Oh my god, that's so funny.
God, bro. Alright. This one's actually kind of rough. I really don't know.
Would you beat me vigorously with
panic?
With
stop.
What?
Just stop. Stop, dude. Just please stop. You know, I just don't.
What?
YouTube, but just I don't want to deal with it. Stop.
Oh my god.
YouTube is literally just gonna cancel
me. The word
me.
vigorously is so funny. I love vigorously.
Because yes.
Steph, do you vigorously beat your keyboard?
No.
You should. Okay, Rev, do you get those also thingy majigs, whatever the fuck they're called?
What are you talking about?
Not yet.
The whatever device?
Yeah.
Yeah.
I need to know if it's good.
Just buy it.
But I don't want to risk it. I gotta know.
I already have one.
Huh?
Oh my
is it
god,
good?
bro. I don't.
On a griddle. Oh yeah, that's what that is. Okay.
Bruh, idolized in your dad's music playlist. That's funny. Found a YouTube channel that uploaded almost 400,000 videos in 6 months. Is that that guy who like automates the process? So okay, we have
1,000 videos in 6 months.
All right. God, bro, this series is really hard. And the worst part is there's nothing to this one doesn't have an answer to it either in the book. Okay, let's think comparison test, right? So
do.
I don't remember how to put the degrees symbol in Google Docs or whatever. I forgot how to do it.
I sure as hell don't.
I forgot how to do it.
There's gotta be something here, man. Am I forgetting anything? Comparison test, limit comparison tests, alternating series test ratio. This obviously isn't an alternating. Ratio and root test don't make sense.
Oh yeah, simmering is just below boiling point.
This is really hard. This is a really hard problem. 1 over. What could I do here?
Immersing in hot fat. Oh god.
Yeah.
Dude, I am at a loss. I might have to skip this one. I'm really trying to think. I mean, I'm thinking there's a clever. There's probably got to be a clever comparison test that I can do with this. That's what I'm thinking right now.
Small amount of fat. Isn't this sout? I think yeah, it's sout. Okay. Stir fry.
1 over.
That's high heat with stirring constantly. Heat. And
I
stirring
mean,
constantly.
we know that cosine squared of x is always going to be between 0 and 1. We know that.
5 to 10 minutes.
That could be helpful.
Alright, I finished another assignment. Let's go.
Everything converges to E. Yep.
That is one more
Everything.
down.
It always
Like 30 more
converges to
go.
E. We're dealing with trig functions, but it still converges to fucking E. I don't care. It's possible. Alright.
What? You're just gonna force it to convert to E.
Oh, dear lord. What do you do in this case? I mean...
It's cold in my room. I might go to bed now. I finished another assignment.
Dude, I am at a loss.
Yeah, I'm gonna go to bed now. I gotta wake up early in the morning. Let's turn this in. Let's turn this bad baby in, and then I'll go to bed.
So this part is always going to be between 0 and 1. Which means that... And that means... Okay, so that means that this series... This series right here has got to be greater than... This is greater than, it continues down here. 1 over 2n, right? Has to, because...
Yep.
Yeah, it just has to be. And 1 over 2n diverges because it's a constant multiple of the harmonic, so I'll just say diverges by comparison test with this, so...
Alright, it's time to go to bed now. I've done enough schoolwork for today. Alright, I'm gonna go to bed. I'll see you guys later.
Okay, good night, what's up? Okay, so this should diverge. I guess, I mean, this isn't like a proper proof or anything, but here, let's just take the sum and just see what happens as values get bigger to see if it looks like it's diverging, since I can't really properly check the answer. Oh, yeah, it definitely diverges. I mean, not definite. I mean, it should. It should. I think that works. The poison raid, let's go. Alright, so using this little fact right here, we were able to show that, so that's nice. I actually liked that problem. It was simple in the end. Alright, so let's go to 7. We have the sum going from 2 to infinity of 1 over n radical ln n so obviously the limit's gonna go to 0, so that's out of the question. In this case, I'm thinking it's a good test we could do here. Yeah, thanks Quinn. Appreciate it. Giga Chad, real. No, I've not beaten Black Blizzard. Alright. What could we do for this? Would an integral test work? Yeah, it would. You could do integral tests for this. But it is a bitch. I mean, let's just try it. Let's see what integral test does. This is gonna suck. You know, first, I just want to take a sneak peek at what the book did for it. Did they do an integral test? Because I don't want to waste my time. Oh, they did integral test, alright. Oh, buddy, alright. Well, let's do integral test. I was right. Alright, so first we need to check, okay, is the function continuous? So we're considering, basically we're considering f of x equals 1 over x radical ln x. Right? That's our function. So, is this continuous on the interval 2 to infinity? Well, let's think about it. Yeah, it should be, because the only way that the only way the denominator is equal to 0 is if x is equal to 1 or if x is equal to 0. So yeah, I would say we're continuous.
Okay, bro, stop spamming.
So we're good there. Okay, yeah, don't spam. You don't gotta spam, bro. We just doing math here. Alright, so we're continuous. The next thing we want to check for is, are we decreasing? And, well, the best way to show that is probably algebraically. So you can just say, okay, obviously 1 over n plus 1 times ln m plus 1 radical. You very obviously this is always going to be less than this because we have a bigger denominator here because we added 1 to everything, and this proves it for the general case. So this is so we can say a sub n plus 1 is less than a sub n for all n. Okay, so that requirement is checked off. Next we need to, so it's continuous, it's decreasing. Next we need to see, is it positive? And obviously it's going to be positive because no matter what you put in here, because we're on the interval from 2 to infinity, so any positive number you put in here is going to be positive. So we can do the integral test. So that means we're going to take the integral from 2 to infinity of 1 over x radical ln x. And so this right here is just an improper integral. So we're just gonna, this is really, so I'm gonna skip a couple of steps here and do a u sub right away. So this is really gonna be the limit as t goes to infinity of the integral from ln2 to ln t of u to the negative 1/2. Should be. Brandon's comprehending what's happening on screen. It's fine. This is like Calc 2, and I'm guessing most people watching this are probably like 14 years old. So
well, wow, you were spot on.
Yeah. Okay. So basically, we got this right here. Yes, I know. I already made u equal to ln x. Yes, I know. I already did it. I already did it, bro. It's already done. It's already done. So, basically, we're gonna end up with the limit as t goes to infinity of 2 radical u evaluated from ln2 to ln t And we're gonna see very quickly that this is gonna diverge because we're gonna end up with like 2 radical ln t and then minus some finite value. So this integral is gonna diverge. And so now we can say diverges, therefore this diverges by the integral test. Let's see if we were right. Yay, I was right.
Ooh, let's go. God, why the fuck do I have 50 tabs opened?
Okay, let's do problem number 8. This is crazy. This shit's going crazy, bro. Alright.
Bro, Poison, you're 14? No. Bro.
Problem 8. We have I already know what to do for this. This problem's gonna be straightforward. Anytime I see a factorial, I'm happy because I know it's the ratio test.
Poison, you know what you should do? Check DMs.
There. So ratio test, we're just gonna do the limit as n goes to infinity. I don't need absolute value for this, but I'm just gonna write it because it's just easier anyway, because it's just a straight fucking line. So 2 to the k plus 1, k plus 1, factorial, k plus 3, factorial,
I'm sad. The chemistry unit for me is coming to an end.
crazy.
Chemistry's probably the only good unit of science.
Where did I get 1 from? For the ratio test, you're supposed to take the ratio. The ratio test says you do the limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n. And basically, if you plug in this case it'd be k, like in this case it'd be k plus 1 over a sub k plus 1 over a sub k, but I mean it's the same thing. Basically, you plug in, you do k plus 1 for all the k's in here, and then you divide it by just the original. And since we're dividing by a fraction, we're just multiplying by the reciprocal, so. The 3, because this is k plus 1 plus 2 after you know, add the 1 to the k term, so it's gonna be k plus 3. Alright.
Bro, why do my neck muscles hurt?
So this is nice because we're gonna see a lot of stuff cancels. So actually, check this out. You can write k plus 3 factorial as k plus 3 times k plus 2 factorial, because the recursive property of the factorial operator. So basically, there's that. So basically,
You're literally speaking a whole different language right now.
cool. Okay, so this right here is actually what that is. Okay, so we can kind of. So now we can see the k plus 2 factorials will cancel, which is really convenient. And then same goes for here. We end up with the k plus 1 factorial is actually just k plus 1 times k factorial. So we're going to cancel another thing out there, right? So this can just go in for this. Crazy. Boom. All right. Yeah, I'm in college. Okay. So k factorials will cancel. K plus 2 factorials will cancel. We're going to be left with the limit as n goes to infinity of... Oh, and then a 2 to the k. The 2 to the k will cancel. We're going to end up with a 2 to the 1 right here. So this is basically going to be 2 times k plus 1 over k plus 3. And we can see very clearly that this limit is going to go to 2. Because if you apply L'Hopital's rule, you'd get 2k plus 2 over k plus 3. Apply L'Hopital's rule, you get 2. And 2 is greater than 1. Therefore, this diverges by the ratio test.
Oh man. Oh.
Alright, let's check problem 9 out.
How many more problems do you have left?
On this review, there's like 33.
And so you have to do 33.
Well, no, I'm not doing all of them tonight. I'm just...
Oh.
I'm probably gonna
And
stop
how long?
in a few more.
How long did that one take you?
Well, I mean, I'm trying to explain stuff, and I'm also doing it on Sketchpad, so I mean, it took me like probably 6 or 7 minutes.
Okay. Yeah, I mean, what do you mean? What do you mean? What career are you studying?
Computer science.
Oh.
Looks really brain hurting. It's not as bad as it looks. If you know, like, if you've actually like been in the course that I'm in, then it wouldn't be that. It's not that bad. You just have to like know it, obviously. So, all right. This we could actually rewrite as k squared over e to the k. And actually, we can be sneaky, I think, and do a comparison test. No, we can't. Well, I mean, we could, but it's a little eh.
How
It's just,
many
like, variables
infinity
and stuff.
signs do you use for each question?
Usually just one. Well, no, if I have to take a limit, then I have to use infinity as well. I really don't. This is like basically this is adding up an infinite number of terms. So like here, I'll show you. So like, let's say you had just a sum from n equals 1 to infinity of n. What this really means is you plug in each value for n going up to infinity, and then you add them all up. So this is really equal to 1 plus 2 plus 3 plus 4 ... until you end up like not really infinity because that's not a number, but it goes to infinity. So basically that is definitely not correct, but you know. Okay. That's basically what we're doing here. So in this case, what this would be, this right here is equal to 1 squared over e to the first plus 2 squared over e to the second plus 3 squared over e to the third dot dot dot. And I basically have to determine, does this converge on a single value or does it go off to infinity? That's basically what these questions are asking. Alright, so let's see what we can do with this problem.
Alright, time to verify Zaza's to poop in circles.
This is kind of seeming like it might be another integral test, but I don't want to do the integral test because the integral test sucks and I hate it. You can't possibly use a calculator for this and be able to. You have to actually prove things. So, all right. Let's just think about this here. Is there anything I can do that would be helpful? I don't think a ratio test would work. Could try ratio test. I mean, my only options here are like comparison test and ratio test. Let's see what we have. Well, and the integral test, but I don't want to do that because I hate that. Let's just see what the ratio test does for me. I'm not gonna bother writing the limit just because I'm trying to hurry.
Alright. I might literally have to nerf some stuff in this level though, because this level's a bit too spammy-whammy.
Actually, yeah, I think ratio test might work really nicely here. Because these are gonna go away. You're gonna put limit. So you have to multiply or anything like that? Well, yeah, of course. You have to do like all the regular stuff that you do. So I'm actually pretty sure this limit, so we're gonna end up with like just a squared term up top, right? Like basically we're gonna end up with k squared plus 2k plus 1 over ek squared, and if you take this limit, you're gonna find that it's equal to 1 over e. And 1 over e is obviously less than 1, so it's gonna converge. It's gonna absolutely converge by the ratio test. Oh, okay, yep. That's what the book used. Alright. Let's check out 10. So 54 times 32, all in my head. Well, let's see. That's really the same as... Yeah, that's just 50 times 32 plus 4 times 32, right? So... 6,100 and then so 6,000 228. Oh, I was way off. I'm really dumb. I thought I had that. I actually thought I had that, possibly. I don't know what I was thinking. Also, Helicon, how's it going? Sorry. I, was too busy being horrible at mental math. Alright.
Don't worry, Rev. I have to stay. If I have to do 6 times plus 4, I just use my fingers always to make sure.
Alright, let's take a look at problem 10.
Yo, Rev, you just got a new subscriber, bro. Let's go.
Oh yeah, crap. Who subscribed? Was it a
Sanjay Singhong?
Oh, is that guy? Yeah. So basically, I could try my best to explain it to you. I basically have.
Imagine like explaining it to a kindergartner.
I mean, you can explain this to anyone, like as far as like what it is. So like basically, let me write this out. I have to determine if. Can I please write the number 3? Okay, so I have to determine if this infinite sum either converges on a single value, so this is gonna like equal some number, or it goes off to plus or minus infinity. So basically what this means is that, so this sum right here would be, you plug in each value for n going up to infinity and then you add them all up. So this is going to be equal to 1 squared times e to the -1 cubed plus 2 squared times e to the -2 cubed, so on and so forth. And yeah. You basically you add all these terms up and you have to determine, does it converge or does it diverge? It's the best way. It's the best way I can explain to you what's happening. I mean, if you're 11 years old, I don't expect you to understand this. So let's see. -n cubed, so this is really equal to... It'll be helpful to look at this as like n squared times 1 over e to the n cubed, right? Which is really just n squared here. There. So that's really what that's equal to. And now, let's see if we can apply a test to figure it out. This one's a little goofy, actually. Let me think about it. This one's a little goofy. E to the n cubed. This one's kind of tricky. Definitely don't want to be doing an integral test on this because that's going to be painful. Is there a comparison test that'll work? Like, I don't know. There's no shot ratio test will work again. I've done ratio tests like 3 times in a row now. No, that seems like it's gonna be ugly. Yeah, that's gonna be ugly. Oh, root test though. Root test, no. Yeah? Yeah, let's try root test. One. Alright. So... let's just see if I can do this properly. So really this is like gonna be n squared to the 1 over n. And in this case, you distribute your powers, so this is gonna become n to the 2 over n over... No, that's not helpful. That's not... no. That's ugly. Damn! Okay. This one I'm kinda unsure on. Like, is there a comparison test I could use on this? I don't know. Like, it looks... So, I could, like, I could get, like, some constant, let's say 2 to the n squared over e to the n cubed, but... I don't know. No, that's just not helpful. This one sucks. This might have to be an integral test. I don't know what else I would do. But that's one ugly integral test. I might skip this one. 10's just really... yeah, we're skipping it. I hate to skip one, but I have to. I'm just gonna lose my mind trying to figure that one out. That one's actually kind of terrible. Alright. So... I already know this is an integral test. I already know it is. In fact, I've done this exact problem before, like 2 times for my homework. So, yeah, I'm not bothering. I'm not bothering with that. I know how to do that. Let's do... okay, let's do 12, I guess.
Okay.
Alright. So... I'm in Calc 2. Literally never seen your channel before, but honestly, keep up the grind, bro. The master's fire, you'll ace the test. Trust. Thanks, man. Appreciate it. But yeah, I'm in Calc 2. Alright, here we go. So, probably alternating series test here. Actually, oh. Yeah. Ratio. Would ratio be good? Let's try the ratio test just real quick. Like, let's just see what happens, just because it's always good to see real quick what happens with the ratio test, because usually ratio test is like the saving grace, right? Yeah, that would actually work because, yeah, I'd rather do this because, oh, n squared, let me think here. Is there a comparison test that'd be easy on that? I don't think so. I mean, there probably is, but I don't feel like it. Whatever. I think we'll go with this test. So, this is, of course, the limit as n goes to infinity. Mind the terrible handwriting. Okay, so if we just multiply these together, we're gonna end up with n cubed, and then we're gonna end up with 25n. 25n. And then yeah, plus n squared plus 25, and then so basically we just have an n cubed term up top. Bottom we're just gonna also end up with an n cubed term. Oh fuck. It's gonna go to 1, and if it goes to 1, then you can't say anything about the series. Oh, okay. It's probably alternating series test then. Let's just do it. So the limit does go to 0. That's obvious because we have a higher degree on the bottom. So we need to check if it's decreasing, which best way to do that would be to take a derivative in this case. So we're going to differentiate x over x squared plus 25, so that's going to be you get sorry, my brain's fried right now. The topic, it's sequences in series. Right now I'm just doing absolute convergence, conditional convergence, or divergence. Okay. So we can tell, you can already tell that you're gonna end up with a 2x squared, and so we're gonna end up with like an x squared minus a 2x squared. So we are convergent by the alternating series test. Now I need to check if it's conditionally convergent or absolutely convergent. And in this case, yep, if n's 1, it's 1 over 26. You're absolutely gaming. Alright. So we converge by the alternating series test, so I'm thinking a simple comparison test will probably do. So we have n over n squared plus 25, so we need to pick something that is less that, wait, that'd be less than that. We don't want that. N cubed, but that, no, that's bad. Wait, College SAT, just a college class. I am pretty sure the SAT does not have this on it. Alright. Oh, God, what is a good comparison test for this? N... Because if you did n over n squared, that would be greater than this. But that would diverge, so that doesn't tell us anything. And if you did n over n cubed, that would be less than, but it converges, so it doesn't tell you anything. I think you probably have to use a limit comparison test. So I'm thinking let's just take the limit. We go to infinity of b sub n over a sub n. So what am I doing? I'm checking to see if this is conditionally or absolutely convergent. We can get rid of that. So let's just see here. We're gonna end up with this limit is gonna end up going to 1. And if the limit goes to 1, that means whatever the series you picked does, the original series will also do. So this should be conditionally convergent by the comparison test, or the limit comparison test with that should be the answer. Let's see if we're right. Oh wait, that was problem 12. Damn it, it doesn't have answers for evens.
Damn.
I'm pretty good. Alright, I think I'll go to problem 16 and then I'm gonna call it a night. So we have 4 more to do. Alright. Let me make sure I got the limit comparison test right. It's so converges if the limit, oh fuck, it's a sub n over b sub n. Oh,
What happened?
I'm an idiot.
No, you're not.
Alright. Here. So this is a sub n b. So a sub n over b sub n. So it's gonna be. But the limit. Alright, I got lucky. So this limit will still go to 1. And. So the limit equals 1. Still. Which means. If we're greater than 0. And b sub n converges. Oh, converges if... Yeah. Okay, yeah. I'm good, because... So, yeah, I was right. I was right, I just got it wrong. Well, like, I was right, but in the wrong way, but I was right. Okay, whatever. We figured it out. Okay, let's take a look at the next one. This is probably a ratio test. Okay, so we're gonna cancel out an n factorial. We can cancel out this, so we're left with a 3 up here. So we end up with this. So we have an m+1 squared up here, so we can actually get rid of one of those. Alright, and this limit goes to 0, which means 13 should be absolutely convergent by the ratio test. Yep, okay. That one's right. On to 14.
Oh my god.
Okay, so we have the sine of n. Can listen to Sputnik 3? I guess. Maybe after this, I could try to put it on, yeah. I think it went off my playlist. Yeah, it did. Alright. So, this one, what would I do? We know we're on that. We know it's between that for all values, right? We know that's true. So this one's rough. I've never had something as simple as just the sine of n before, and it's throwing me off. Not even gonna lie. There's gotta be something I can do here. Sine of n. Huh. I have a feeling that it does converge, just because eventually, like, after 700, or after 360 inputs, you should go back to 0. What? Let me see. Oh. Wait. Hold on.
What's up?
Oh, it's because this is in radians. I don't know. Taylor series expansion. See, the thing is, I haven't... I know what that is, but I haven't learned it technically in the class yet, so it's not going to be useful for me on the test. Like, I mean, I know I could just, you know, whip out the... Well, even then, I would have like a sum, I would have like a nested sum, which would be kind of goofy. Why is this, like, hard? There's gotta be... There's gotta be something here, man. Sign of N, it's so simple. I've never had one this simple and I can't do it. I might just skip to 15 and 16 because I've been streaming for an hour and a half and it's getting late.
Damn it, bro. Why is it so hard?
Like, the sign of N, what would that be? Like, how would you deal with that? Yeah, I don't think I'd have a problem like that on my test anyway, because we haven't done a problem like that in class before. And of course that's an even problem, so I won't be able to... Wait, 15 is just confusing, hold on. I'm just doing one more and I'm gonna go to bed. Let's just do this. Let's just do this and I'm done. I'm so tired, man. Pretty confident I can get this one done at least. So the limit does go to 0, so unfun. Alright. Let's think about this here. Okay, let me go back to the playlist. I don't really care. Yeah. This thing really just like... Well, can I shuffle, please? Let's just finish this off. So, Sorry, I'm just so fried right now. Alright. Calc 2. Man. I know that I already know this is a limit comparison test. Let's see. It's just gonna be let's just try 1 over n and see what happens. So That's gonna go to 1. Alright, there. I'm gonna call it done.
Okay.
We got through... We did like 13 problems, I believe. And I was like being really slow for them. I have another day to study for this, so I think I'll be fine. But yeah. Cool. I guess I'm gonna end. And I'll play EXO again tomorrow. It was just so late already tonight, and I figured I might as well just get some studying in at least. So, yeah. I'll see you guys tomorrow. Thanks for watching, for everyone who is still here. So, yeah. Oh yeah, I'll listen to it and maybe add it to the playlist. Sorry, but I gotta go. So, I'll see you. Good night, guys.